Okay, so now let's talk about sedimentary environments. Where are you going to find sedimentary rocks? Well, it's going to be any place that you accumulate sediments. So if we go back to a previous slide here, we said that sediments could accumulate in a river. They could accumulate where in front of a glacier. They could accumulate in a desert. They could accumulate on a beach. They could accumulate underwater, like a lake or an ocean where materials are accumulating on the bottom. So now if we go back to this picture, these are all places where you find sedimentary rocks. So sedimentary rocks can be found in, can form in a river basin. They can form in a desert. They can form on a beach. They could form where a river empties into an ocean. That's going to be a delta. They could form next to a glacier. They could form out in the middle of an ocean where sediments have accumulated on the bottom of the ocean floor. So how are sedimentary rocks classified? So here we have how are igneous rocks classified, and we said that there were two criteria. So what were the minerals that the igneous rock was composed of, and then what was the texture? And the texture was things like aphanitic texture, phaneritic texture, vesicular texture. So we're really going to do the same thing for sedimentary rock. So we're going to have what is the sedimentary rock composed of. So it could be composed of calcite, or it could be composed of quartz, silica, or it could even be composed of organic materials like carbon. Then going up and down is going to be the texture. And so let's look at the different kinds of textures that a sedimentary rock can have. So there are three basic textures. So you have clastic textures, which means it's composed of pebbles and rocks that are glued together. You can have bioclastic, which means that it was organically made. It was made from living organisms that made like shells and things, and then those shells were glued together. It also can be made directly from the precipitation of water in crystalline form. So those are going to be your three main kinds of textures. Then when it comes to clastic textures, you can subdivide it based on the size of the particles that are being glued together. So it could be boulders that are glued together, gravel pieces that are glued together, all the way down to clay-sized pieces that are glued together. All right, so here's our sedimentary identification chart, and we're going to look at the detrital types of rocks. Then we're going to look at the chemical precipitate types of rocks, and then we're going to look at the biochemical types of rocks. So the first one is going to be the detrital types of rocks. So again, these are going to be other pieces of rocks that have been glued together. So you should know that clay, the rock clay is going to be composed of clay-sized pieces of materials that have been glued together. They're so microscopic that you cannot even see them with the naked eye. On the other hand, you do have things like conglomerates, which are composed of things like pebbles that have been glued together. Now you do need to know the difference between a conglomerate and a breccia. A breccia is going to be composed of angular pieces of rock. So pieces of rock that have sharp edges that are glued together, but conglomerates are going to be made of pieces of rock that are rounded. So that gives you an idea from where they came from. So a conglomerate came from a river where the pebbles were rolling on the bottom of the river channel, and that's what made them round. So that gives you a clue as to the origin of them. Okay, then you got your chemical precipitates. So these are things that start out as being dissolved in water, but then for some reason they precipitate out and they accumulate on the bottom, and then the crystals interlock with each other. So for example, you're going to have things like halite, which is composed of salt. So this is going to come from an environment where it's very dry. So if the ocean evaporates, it leaves behind large quantities of halite. Same thing for gypsum. So gypsum is going to come from an environment where evaporation has occurred. Okay, then the next kind is going to be limestone. So limestone is going to come from calcium carbonate that precipitates and then turns into limestone. And then as groundwater percolates through limestone, it can carry in magnesium. And so calcium carbonate, when you mix it with magnesium, becomes calcium magnesium carbonate. And then what that is dolomite, or dolostone. So dolostone would be the rock which is composed of dolomite. Limestone is the rock composed of calcite. So the difference is if you take calcite and you start to put a little bit of magnesium in there, then that turns into dolomite. And then when dolomite turns into a rock, that's going to be dolostone. Another thing that can happen with calcite is once it forms, it can be dissolved away, and then that makes a cave. And then when new calcium carbonate comes back into the cave, it makes travertine. So travertine is also made of calcium carbonate, but we just don't call it that. So instead we call it travertine. And then bauxite. Now bauxite actually is a rock, and it's composed of clay, in particular aluminum clays. And so we can, bauxite is an ore, and we can get that aluminum out of the bauxite. So a little bit of ocean chemistry here. So you will not need to know these chemical formulas for the exam. But the idea is that carbon dioxide, which is CO2, so notice this is CO3 over here. So carbon dioxide mixes with H2O, water, in the ocean, and it also mixes with calcium, and you eventually end up with calcium carbonate. So if you want to read that, go ahead and do it, but just know that limestone comes from the mixing of carbon dioxide with ocean water to make calcium carbonate. Then you got your biochemical ones. So these are going to be rocks that get their sediments from organic materials. So the first kind is going to be chalk, which is going to be composed of microscopic shells composed of calcium carbonate. And so on this slide, it shows that they are foraminiferous. So they're microscopic little organisms that made their shells out of calcite. And then those microscopic shells got glued together to make chalk. Okay, but chert is made very similarly by microscopic organisms that use quartz to make their shells, and then when they get glued together, then they turn into chert. Now there's another way of making chert though. So you can also make chert when the quartz precipitates out of seawater, and it can make layers of chert. So there's two different ways of making limestone, and there's also two different ways of making chert. So limestone can directly precipitate out, but calcium carbonate could also be taken in by organisms and then to make shells, and then they're glued together, and then that's going to be fossil limestone when that occurs. Then you can also have plants. So in a swamp, a tree dies and it falls into the swamp. But before oxygen can get to it and decompose the plant, another plant falls on top of it. And then another plant falls on top of it. And so the net effect is you've got all of this organic material that starts to accumulate. It gets compacted together and it turns into peat. And then eventually peat can be turned into coal. So that's where coal comes from. Okay, so let's take a break, and when we come back, we'll talk about what do sedimentary rocks tell about their history.